that mean to the right forever? So if I start going like out the right side like this, where's the function headed? What is its value headed towards? It's approaching 1, isn't it? It's approaching 1, and this is the y value, right? So here, x was going to infinity, the function was going to 1, right? X was going out to the right forever, the function was headed towards a number. Does it ever necessarily get to that number? No. Okay. Compare that to this function. Let's say that's the number 1 there. Here, I think I'll draw the function on the other side also, like that. On the graph on the right side, as x goes to 1, where does the function go to? The function goes to infinity. Those are completely different concepts, aren't they? The one on the left, what part of it's going to infinity? The x, and the function goes to a value. The one on the right, the x goes to a value, right, 1, and the function's going to infinity. Right? Okay. We're going to investigate both of these things today. That's what this section is about, looking at these two scenarios. So the first thing that we should note, and this is 1.6.10. It says that if you have limit and you want to see what happens as x goes to infinity of 1 over x to the n, you should get 0. Now this works when n is equal to 1, 2, 3, 4, any positive integer. This is a big formula you should remember. But I don't want you to remember it like that as a formula. I want you to remember it more conceptually. I want you to look at it like, if in a limit you have the form of a fixed number over something that's becoming infinite. So look at that limit up there had 1 over x to the n, right? 1 over x to the n. 1 on top is a fixed number. The bottom, though, x is getting bigger and bigger and bigger, isn't it? So anytime you have a number on top that's not moving over a number that gets bigger, what happens to that ratio? It goes to 0. It gets smaller, right? That's one of those concepts that everyone here needs to understand. And you can give yourself an example next to it, like 3 over 10, 3 over 100, 3 over 1,000, 3 over 10,000. Look at those numbers. That sequence of numbers is getting what? Bigger or smaller? Smaller. It's getting closer to 0, isn't it? The numerator is staying the same, but the denominator is getting bigger. Anytime that happens, it goes to 0. And it also turns out that it doesn't matter if it's positive or negative on the top or the bottom, okay? If you had a negative 3 over something becoming infinite, it would still go to 0. So that's the one I think you should think, be able to think clearly about, something like that. So let's look at our first example, and we'll apply that. We'll see how this is all going to work out. Okay, as an example, find the limit as x approaches infinity of 3x squared plus 2x minus 5 over negative 4x squared plus 7. What are the limits that you've done, like at home and that we've done in class? What are the forms that we've seen that we've worked with so far? Over 0, we've seen fixed over 0, haven't we? And we've seen 0 over 0, haven't we? Those are the two we've seen. Now we have something new, all right? This is the first time we've seen something like this. We're trying to let x go to infinity. Infinity is not a number, is it? Right? Infinity is an idea. It's the concept of letting x get huge. So, but we still try and do it the same way we did before. Like if we were saying let x go to 2, we try plug 2 in. Let's try and plug the idea of infinity in and look at what happens in the numerator. What do you think infinity squared would be? Yeah, have you seen that commercial? My 3-year-old loves that commercial. I don't know why. She's like, she sits there and walks around. She's like doing that thing. That little girl. Yeah, that one girl says, "What's infinity plus infinity?" And the other one says, "What's infinity times infinity?" And they all go. Pff. Turns out they're the same answer. Okay, infinity plus infinity, infinity times infinity are the same thing. It's infinity. Okay. So x squared, infinity squared is infinity times infinity is still infinite, right? It's infinitely big. Plus, well, times 3 out front. What's infinity times 3? Infinity. Plus 2 times infinity is still infinity, right? Take away 5, big frickin' deal. It's infinitely big. You take away 5, it's not even slowing it down, right? It's still going. So your numerator is headed to where? Infinity. Where's your denominator headed? So let's go and plug in here. What's infinity squared? We said it was infinity, right? Times negative 4. That's negative infinity. Plus 7, again, who cares? That's not going to slow us down. So the bottom is headed towards negative infinity. What I can tell you right now is that I'm headed towards, if I'm even headed towards anywhere, it's a negative number, right? Possibly 0, though. I could be headed towards 0 through negative numbers. But I cannot tell. So just like we said before, 0 over 0 I said was a bad thing. We needed algebra or trick, right? 0 over 0 is never 1, right? We never say that's 1. And we don't just stop and say, you know, undefined. That's not what calculus is about. We had to do something with that. When we see infinity over infinity now, we've got to do some work. Okay? Some algebra, some trick. So we're kind of back into the same boat that we were before. Algebra, trick. Question is, what's the trick? So let me put this down here. There's a standard practice when you get infinity over infinity. I mean, a standard approach, I should say. When you get infinity over infinity like we did here, what you want to try and do is divide out the highest power of x in the denominator. So you want to look at the denominator. What's the highest power of x in the denominator? X squared, right? I want to divide out an x squared. So how would I do it? Let me show you what I'm going to do. I'm going to leave a little space in the front of this fraction here. The only way I can get rid of the x squared in the bottom is to come in here with the 1 over x squared and multiply that through. Wouldn't that get rid of the highest power of x there? But I can't just come in with 1 over x squared on the bottom. Whatever I do to the bottom, I have to do to the top, don't I? So I have to do a 1 over x squared on top also. This is the standard trick for infinity over infinity. At this point in this class, that's what we do. Later on, we'll have another way of handling this. So let's distribute through here and see what we get. And I'll take this first one kind of slow. Distributing through, I get 3x squared over x squared plus 2x over x squared. This thing's driving me crazy. Minus 5 over x squared. That's just the numerator. Over the denominator, negative 4x squared over x squared plus 7 over x squared. Everyone see that just distributing term by term? And you should get some good cancellation here. X squared should go away there and there. What will I be left with on that second term in the numerator? Just 2 over x, right? One of those x's are going to cancel. And then over on the second one here, nothing cancels. I mean, the third one, nothing cancels. And over here, nothing cancels. So I've got limit x goes to infinity 3 plus 2 over x minus 5 over x squared over negative 4 plus 7 over x squared. And now at this point, let x go to infinity. So what happens to the 3? Well, there is no x next to it, right? So it's just 3. What's 2 over x, though? What's that go to? It goes to 0. Why? Because it's a fixed number over something that gets huge, right? Fixed over infinity goes to 0, which is what I just wrote up here, right? That big box thing, fixed over infinity goes to 0. So that's going to blow up. It's going to not blow up. It's going to go to 0. It's going to vanish. The 5 over x squared is also fixed over infinity. That's going to vanish. In the denominator, the negative 4 is going to stay, and the 7 over x squared is going to vanish. So after you do the limit, you don't need to write limit anymore. It's just 3 over negative 4. So this thing is headed towards negative 0.75. Okay. I'm going to do one more and we'll take our break, okay? How about, I'm going to kind of skip here a little bit. Whoa. Limit x goes to infinity, 3x plus 1 over square root